Welcome back, Chappelle. Welcome back to it. Welcome back to your flip class with the hero PP. I know. You're going to get to go to class today. Are you excited? Welcome back to your flip classroom, our continuing discussion of the scientific revolution, right? So the big thing about it is, like, we have an extra student today who's going to come to learn about the scientific revolution. His name is Pierre. But yeah, coming to y'all live, of course, from my house at about right now it's about 6:50 in the morning or something like that, Pierre, right? You're very sleepy. You're trying to go back to bed. Now, the big thing about it, though, that we need to understand is we're going to continue our discussion from our last flip, right? I know it's crazy and ridiculous that we have this day and stuff like that, but it's for y'all's safety, so we don't have to worry about y'all going around in that weather, right? So the thing that we need to understand, though, is we are going to have a pretty intense couple of days, though, because we're going to be learning a lot from flips, right? So, of course, what you need to make sure you do, go back, bang out that warm-up, right? Do a good job on it, because I'm going to be checking it at the end of the day to make sure that you did it. And then also make sure you do well on that Google form, right? Now, the Google form is going to come after this, right? And the Google form is going to be graded with your warm-up for an extra daily grade to make sure that you are doing and paying attention to the flip content going into everything. Now, look, a couple other things you need to pay attention to as well. Remember, B period, you're going to have another flip due next class, right? Because this is our class flip, and then our next flip is your homework flip, right? So there will be 2 flips posted today, okay? And you're responsible for both of them, all right? Now, the thing about it, though, is like C and E period, y'all have a little bit of extra time to get that other flip done, whereas B period, you got to get that second flip done tonight before you come into school tomorrow, okay? Now, speaking of some quizzes and stuff, though, as well, you do have a quiz coming up on all of these scientific revolutionary thinkers. It'll be a simple matching quiz, right? A simple matching quiz where you'll just have the description and you just click and choose each person, right? It'll be a word bank of people. It'll be very, very simple as long as you study. But it's not going to be the next class B period. It's going to be your class following that. So y'all's quiz B period will be on Thursday. Everybody else's will mostly be, and C period will be on Thursday, and then E period yours will be on Friday, okay? So make sure you pay attention to that schedule, stay on top of your stuff, but let's get after it and let's finish up this scientific revolution before I create this flip this afternoon about the reign of absolutism, right? So going into it, though, we are wrapping up the scientific revolution right now in this flip, so let's remember what we talked about last time, right? So last time we talked about, of course, the coming off of Nicholas Copernicus, right? His publishing of De Rev, talking about the universe a lot, continued to talk about the planets and the way that they were set up. We discussed retrograde motion and how that's going to kind of be the thing that kind of is like the Achilles heel and all these astronomers' ideas. But then you're going to see a progression of other scientists pop up. Tycho Brahe, the Danish scientist, of course, that was missing his nose and stuff like that because he lost it in a duel against his cousin. But he's going to be that guy that's given an island by the Danish king to do all those observations of the night sky, right? And he tracked the movement and actual movement and location of over 777 different celestial stars and objects, right? So that's a really, really important. He's also going to see a supernova happen, right? So he's going to, one, realize that everything out there is not perfect. It's not where heaven starts because there's stuff exploding and moving and things going around in constant change. And then also that tracking of those 777 different stars is going to provide ample amounts of data, which will be published in a set of tables later on called the Rudolphine tables. And his assistant, Johannes Kepler, is going to actually move to the Holy Roman Empire, where he is actually a German scientist. He's going to take that data with him, and he's going to use that data to perfect the shape of the orbits. And he realizes in that moment that you can fix the retrograde motion problem if you just change the orbits into ovals, right? They're not perfect circles, they're actually oval in shape, right? And the other big thing, obviously, he realizes too is laws of planetary speed and stuff like that the planets actually get faster when they get closer to the sun. And then last but not least, Galileo comes along and he uses his telescope, Kepler's ideas, Brahe's ideas, and Copernicus's ideas, and unifies them all together, and he proves heliocentrism. Even though he ends up in a little bit of hot water later on when he pisses off the church, and of course they put him under house arrest for the rest of his life. And then of course he gets his middle finger stolen and stuck in a jar. So going into it though, when we're talking about this whole thing, you now have to understand that these scientists, they're astronomers, and also the scientists that came before them, kind of really, really kickstarting this entire new culture, is going to lead to a new society in European history century where science is going to be based more on observation and experimentation instead of church law and assumption, right? You're now going to be growing into a society where people want to design experiments, where they want to create new ideas. And this was the last slide that you had on your last flip, where we're talking about Francis Bacon, the ideas of actual like observation, scientific study, and the growth of the scientific method, okay? So let's talk about this guy a little bit by the name of Francis Bacon. No, not the guy that invented bacon. Apparently is from the region that invented bacon, right? Like, so now the thing that we need to understand about Sir Francis Bacon, though, is he was a member of Parliament, and an educated member of Parliament at that, right? We'll talk more about what Parliament is and stuff like that, but he's actually also going to be kind of in tandem with a king that we're going to talk about in this unit as well. He was a member of Parliament and then also a financial minister to King James I, right? The same guy that Jamestown is named after, okay? And the big thing about Francis Bacon is he's going to capitalize on this entire idea, and he's going to begin to write a book about the culture that the scientific revolution has created. A culture where scientists are now kind of civil servants in a way, right? Because much like he was a member of Parliament, he believes scientists are now people that are there to make everyone's lives better, right? They are there to design experiments, create new data, and create more like things that are meant to actually inspire society to be better, right? And in one of his most famous books, New Atlantis, he advocated for a building where people could bring their problems, kind of like the Hogwarts of science, right? Where you could bring your problems up to the scientists that live there and be like, hey, my crops won't grow. And they'll be like, oh, well, bring us some dirt, right? And they'll perform a scientific experiment to figure out maybe why your crops won't grow. Or your sheep dying? Let's figure this out. Oh, it's like, what's wrong with Pierre? Why is he so nervous all the time? We designed a scientific experiment in this big new house that Francis Bacon advocated for to figure that whole thing out, right? The thing about it that you need to understand, though, is that in creating this like fictional place, this like new Atlantis building where all of these problems would actually be fixed and designed, basically, in essence, Francis Bacon designed the scientific method, right? That thing you learn every single year in high school where it's like hypothesis, experiment, observe the results, conclusion, etc., etc., etc. And he got so good at it, he actually is the thing that ended up killing him. No, he didn't eat raw chicken and get salmonella. Fun fact is he actually was in his carriage one night riding back to his home, and he actually was like really curious when he saw snow start falling outside of his carriage. And he was wondering like, well, will meat preserved with snow, this could be a way that maybe poor people could figure out how to preserve meat for longer. If it's snowing outside, can you preserve meat for longer if you stuff or pack meat with snow, right? And so he actually went and he bought a chicken, right? Like, so he bought a chicken from a nearby village and he plucked all the feathers out of it, and then he excitedly ran into the snow and started shoving snow inside of this dead chicken, right? Well, he forgot to put a jacket on, he got pneumonia, and he died, right? Like, so scientific experiments and scientific method will get all of us eventually, I guess. Now, the next guy that we're talking about has one of the worst haircuts you've ever seen in your entire life. This is none other than Rene Descartes. He is actually a French scientist who's really going to start kind of expanding beyond those walls of the scientific revolution. He's not going to be an astronomer. He's not going to be a scientific method guy like Francis Bacon. He's kind of his own thing, and he's very hard to explain sometimes, right? But the biggest thing that you need to understand about Rene Descartes is that he is a French polymath, okay? He's a French mathematician. He is a geometry expert. And then also the other big thing about it is he begins to ponder the concepts of existence, right? So what we need to understand about Rene Descartes is he is going to create new types of mathematics. He's going to write philosophies, and he's also going to write arguments on existence. This is going to be the guy that tries to bridge the gap between scientific thinking and philosophical thought, right? Now, let's start off with his math stuff, right? So Rene Descartes is actually going to create so many different elements of mathematics, you'd be surprised. One of them in particular, you still use. It's actually a thing that he created called the Cartesian plane, right? Renamed after him, Rene Descartes, right? It's known as the Cartesian plane. The Cartesian plane is the x and y axis that you use in geometry and algebra to plot points, right? Apparently one night he was sitting in his bed and he was like looking up at the ceiling and he saw a fly buzzing around his ceiling going bzz, bzz, and it kept landing in different spots, and he was like, oh, if I draw lines on this, I can actually figure out where that fly like landed like periodically throughout the night, right? And he created the x and y axis graphs that you actually use now. Now, the interesting thing about it, though, is the question that he grappled with more than anything else is, well, apparently in this new scientific era, he really was wondering, though, but how do I even know any of this exists, right? How do I even know, like, the human mind is such an expansive thing. How do I know it's not playing tricks on me? How do I know that I even exist? Is this even in existence? What's going on? And apparently he deduced it down to one simple quote. He said one day, cogito ergo sum, which means I think, therefore I am. Because he couldn't grapple with the idea that everyone exists because he knows he does, because if you have cognizant thought, that means you must exist in some place. And we'll talk about that a little bit more in class and stuff like that, expand on those ideas a little bit and kind of try to better understand them as we go forward, right? And we'll actually review his stuff a lot because it is pretty tough to understand, right? But going into it, just know that he couldn't figure out if he existed or not. So the next one that we're about to talk about is some breakthroughs in medicine, right? So like medicine and basically how like medicinal science is actually operated, right? So going into it, you need to understand that scientists and doctors right around the beginning of the scientific revolution are finally going to start performing those bad boys known as autopsies, right? Now, as scientific advancements has actually gone forward, scientists are now beginning to understand that there is like some basic value to the like performing an autopsy after someone has died, right? Dissecting the body to look for a cause of death and then also for some scientific study, right? So one of the very first people to come along to actually perform autopsies on dead donated bodies is going to be a guy by the name of Andreas Vesalius. Now, a lot of people say that autopsies were like illegal before this because the Catholic Church forbade them. That's not actually necessarily true. It's mostly due to the fact that the people that had died just didn't want their bodies cut open, right? So now going into this moment in like history, though, you've now got enough scientists who have patrons, though, that are willing to pay families for these bodies, right? So Andreas Vesalius is going to be an Italian medical scientist, right? And he's going to create some of the very first medical textbooks ever created. His most famous book, though, is called De Humani Corporis Fabrica, on human anatomy, and it's going to successfully discover muscular structure, internal organs, the skeletal structure, circulatory system, the nervous system, and he's going to do all of this by simply performing autopsies where he would slowly peel the skin off of dead bodies so he could go layer by layer to see the connections of muscles and ligature and also the vascular system and things like that, and he would reanimate all of these bodies as well, and he would record them in his textbook, right? De Humani Corporis Fabrica actually has one of the most insane sets of illustrations you've ever seen in your life, where he would have like actual like human bodies without skin or the internal organs removed, like kind of propped up using rope, and he would actually design like, or he would actually sketch them all out in engravings. This one right here is my favorite one, this skeleton like pondering and stuff like that. I don't think I could ever get a tattoo because I'm afraid of needles, but man, if I did, that'd be one that I'd want to get right there. That thing is dope. The thing about it, though, when we're looking at it, though, De Humani Corporis Fabrica is going to be a massive leap forward in the study of the medical sciences, and Andreas Vesalius is going to be the guy that actually really begins that study of anatomy, right? Now, fun fact about De Humani Corporis Fabrica is usually when books were bound back in the day, they were usually done with leather, cowhide typically, and stuff like that. De Humani Corporis Fabrica, fun fact, was actually bound in human skin because he had a lot of it laying around. So like now, good job, Andreas Vesalius. So going forward as well, you need to understand this little device, right? Now, this little device right there is going to be a massive breakthrough in both the medical sciences and also microbiology. Some of you are like, that looks like a ping pong paddle. Well, it's not. That bad boy right there is none other than Anton von Leeuwenhoek's microscope, right? So what you're going to see also during the scientific revolution is the birth of microbiology, which we know as well later will actually be heavily applied to the medical sciences, right? Now, Anton von Leeuwenhoek is the guy that actually perfected the microscope that we just looked at 2 seconds ago, right? That gold little paddle thing, and this is him actually putting it up to his eyeball. Actually, fun fact, as you can see, it's pretty small. Like, you would think when you look at it that it's going to be a pretty decent size, but it's actually pretty tiny, right? You would look through that little, like, optical area, the lens right there, and the specimen would be actually mounted right behind it. And so what he did, though, Anton von Leeuwenhoek, as a Dutch scientist, he perfected his microscope, and he's going to be the very first person to view protists or protozoa, basically small organisms, and also even bacteria, right? He observed spermatozoa and stuff like that. Now, the other thing that you need to understand, though, is he did this by perfecting his observational techniques. And his most famous example of this is when he actually looked at a slide of pond scum, right? He actually went into a pond near his house, and he got a little bit of water off the pond scum off the top, and he put that on a slide, and he actually looked through it, and he could actually see multiple multiple organisms moving around in that water and in that pond scum that are not visible to the human eye. Now, the next guy that comes along is an English scientist. He's a man by the name of Robert Hooke, who's going to perfect another microscope, which is much more equivalent to the ones of the modern era. And it's sitting right behind him in this picture right here, right? Looks a lot more like a modern microscope you might see in one of the labs, right? That at our school. So now going into it, though, he also is going to use it to observe some microbiological things as well. You know him from your biology textbooks for when he did this, when he observed cork cells, right? Cork cells actually taken either from a wine cork or from the cork bark of an oak tree, and he actually is going to be the very first person to pioneer the ideas of cell theory, right? Because he's going to realize that human or like living things are made up of small different individual units known as cells, right? And so he's going to actually like pioneer that entire concept. But the interesting thing about Robert Hooke, though, as well, is that he drew everything he saw, right? That right there is his microscope using a lighting source, of course, that he's going to create. And he's also going to draw everything he saw. That right there is one of his recordings of a flea that he actually captured and put underneath his microscope, which is really, really cool, right? Now, the guy that comes along, though, and links all the sciences together is probably one of the most important people in the entirety of the scientific revolution. He's a guy that I love to talk about as well. We're talking about none other than this guy, the famous apple hit me in the head man, which that actually never actually happened. Isaac Newton might be one of the most important people of the entire scientific revolution, right? An English scientist who is going to be alive from about 1643 to 1727. Now, why out of all the scientists do I have this guy's years on there of his birth and life? I think it's really, really important as we book in the scientific revolution together just to understand how many years this thing took up, right? When you really look at the scientific revolution, starting all the way back in 1543 with Nicholas Copernicus publishing De Rev, theorizing the idea of where the Earth sits in the universe, and really kind of ending off with Isaac Newton, who doesn't die until 1727. As you can see, the scientific revolution is almost 200 years long, and it's going on in the background of everything geopolitical that we will talk about during our era of absolutism, right? So keep that in the back of your mind that the scientific revolution is actually happening during that era of absolutism and constitutionalism, right? Now, Isaac Newton is going to be extremely important for a lot of different reasons, right? Famously, of course, he is going to be the guy that secondhand Fig Newtons are named after, right? Because Newton, Massachusetts is actually named after Isaac Newton, right? But of course, they are then going to invent the cookies called Fig Newtons in Newton, Massachusetts, and that's going to be why they're kind of like not named after Isaac Newton, but they kind of are at the exact same time. So going into it, though, also that we need to understand, he is a physicist and a polymath, right? He is going to be the guy that kind of uses mathematics and physics to link all the scientific branches together, circling back around all the way back to our universe stuff, so we can understand how the Earth goes around the sun and what force keeps it locked into place, right? Well, the big thing that we need to understand about like Isaac Newton's early life is he actually was super pious and weirdly into alchemy, right? Now, the really, really quick thing that's what I mean by that is he was very religious, right? He was extremely religious and he was obsessed with a lot of really different little things like in his early days, right? He was really obsessed with figuring out two things. Alchemy, which is, of course, like how to like turn random elements into other random elements, which he learned later in life isn't possible. And then, of course, he was trying to always obsessed with figuring out the day the world would end, right? Now, he got pretty close to figuring out when the world would end, he thought anyway, when in 1665 and in 1666, two terrible tragedies are going to strike London, right? And what's going to happen in London is one, the Great Plague of London, when an outbreak of the Black Death Plague will actually pop up in the 1660s. And then another one that's going to happen is known as the Great Fire of London, when over a third of London would be burned to the ground because of a fire that started in a bakery on Pudding Lane. So now going into it, what we also need to understand, though, is why are those two events important? Well, the thing about it is he's going to run away from London, and he's going to abandon some of his work on pious ideas and alchemaic sciences, and he's going to end up in the countryside where his family had an estate. Now, while he was actually on that estate, while he was avoiding dying from the plague and then also from the great fires that were sweeping all over London, he begins to use his observational sciences, and he begins to kind of actually do work on something he had been really curious about for a long time, the forces of gravity and calculus, right? Now, apparently, he then, while he was not in exile, but like actually in hiding in the countryside of London, he comes up with the concept of gravity. Now, this, of course, is the origin of the story where apparently he was sitting under a tree and an apple fell and hit him in the head. That actually didn't happen. He made up the story about the apple so he could explain the concept of gravity to people that didn't know what it was, right? And inadvertently, to develop the concept of gravity, he had actually prove it mathematically, he had to develop a new form of mathematics known as calculus. And he records all of his ideas on the law of universal gravitation, and on his ideas of calculus in his most famous book known as the Principia de Mathematica, right? And he publishes that in 1687, catapulting him into fame, right? Now, later on, though, he's going to expand his works into physics, energy, and he's even going to create some theories on optical light after he becomes the president of the Royal Society, right? And the Royal Society, of course, is this group of scientists in England who do nothing all day but study science and try to figure things out. And that's why in the 1700s, he published this idea. He's also the guy that figured out and realized that white light is actually a combination of all the different colors of light. He used a prism to split and separate light using what's known as a camera obscura that had been developed hundreds of years before, right? And he used this prism to realize that all light is, of course, or white light is the combination of all light, and the light that we actually see is light reflected back into our eyes, right? So this genius is going to be the guy that comes along and really perfects the entire scientific study of the scientific revolution. But that is it right there. Y'all go finish up that little Google form after you watch this. And of course, B period, y'all got that other flip that you need to take care of going into our next class, right? But I'll see y'all then. Y'all